my name is Eric, and I am a student in cloud computing, and this is my submission for assignment 1. The goal of assignment 1 is to create two EC2 instances that read from an S3 bucket. The first EC2 instance is going to read from the S3 bucket, run the Amazon AWS recognition API on the image, and it's going to extract images that have a confidence of 75% or above out and push that index into an SQS. At the same time, we have a second EC2 instance that's constantly listening to the SQS and verifying that there's something coming through. And when something comes through, it's going to take the SQS index, run, check, look up the index from the S3 image bucket, and this time it's going to use the AWS TextRact API to take the index of the image and output the text and store it into a text file. And with that, let me show you my code. This is my face-to-text code. In my face-to-text code, I declared a bucket name and the queue URL. For my project, I used the first in first out SQSQ. I use this primarily because I wanted to ensure that the requests that I put in go in the order that I wanted to go in. The first function is to get image. Now, get image is a simple function where it just gets the index.jpg. So 1.jpg would return me the first image, 1.jpg, and it's going to build it and return it back. Now, this is specific towards the AWS recognition API. And I say this primarily because later when I talk about the TextRact API, it's slightly different. These two functions are essentially the same thing. The only difference between this one is that this is going to send in the termination signal. I wrote this a bit different. I wrote this secondary because I wanted to ensure that it was a second function call that was being made later in the code when it's executed. This basically all it does is that if a confidence of an image is detected with 75% or above, it's just going to send the index to the queue, and that's it. Specific to first in first out, we have to have a message group ID and a message deduplication ID, so that we don't constantly send the same message over and over again. And it's to ensure that we're sending it to the right group. Over here, our code is very simple. We have a while flag which constantly checks the S3 bucket, and it's going to extract each image out. It's going to put in a request to detect the face from that image, and it's going to detect faces from that request and store the result here. Now, if the face is found with a high confidence, it's going to set this flag to true, and it's going to go here to this if statement, and it's going to push that index to the SQSQ. And once we are out of images to read from the SQS bucket, from the S3 bucket, it's going to send an error, and when that error happens, the flag is going to be set to false. It's going to exit the loop, and then it's going to send the final message of -1 to terminate the queue. Now on the other side, which is text detect, the starting is very similar. We declare our bucket name, we declare our queue URL, same thing. Over here, the first function is to get the image, but how this is different from AWS recognition is that for TextRact, we're retrieving the data type of document, because for a For the text track function, what we're trying to get is the text to, get a document out of. Uh, to detect text from image, that's the second function. So once we get the image, we're going to send that image into this function, and we're going to put in a request to analyze the document, and then we're going to take the analyze document request, we're going to get the response, and we're going to build a string, and we're going to set this boolean to false. Now, this is a bit important because we're going to analyze this in blocks. For every single block that was detected from the image that we detected, we're going to go block type line by line, block type line. So we're going to go line by line. This was important because this is a block I faced, because initially the function was a data type, block, which would go by each block. That got deprecated, so we have to go line by line. For detect to text, we're just going to go and append each block of text line by line and append it. Over here, this is where we're going to write to our file. This is our function where we write to our file. It's pretty simple and straightforward. All we're doing is taking in the values that we inputted, the index number, which is what we want, the text, the S3 object key, and the text detected boolean. The text detected boolean just says if the text was detected. S3 object key is just the key for the S3 object. The last function is to delete the message from the queue. Once we get it from the queue, and once we're done detecting the text from the image, we're just going to delete that from the queue because we don't want to overcrowd our queue. Over here, same thing. We have a while loop, and we have a flag. These two lines, we are basically getting the request from the SQS bucket. Over here, we have the max number of messages that we're going to get, which is going to be 5 messages, and we have a wait time of 20 seconds each time, so we're going to ensure long polling. Once we have that, we're going to receive the message. The message comes back in the list in a list type, and the data type is a message. For every message in the message, we're just going to go through each and every single one, get the image, detect the text from the image, delete it from the queue. The only difference is that in this one little line right here, when we're extracting out the message body, if the index is -1, we're going to enter this, terminate the program, set the flag to false, delete the message from the queue, and then break it. And without further ado, let me show you how the code works. So these are my two EC2 instances. I SSH'd into them using PuTTY. This is EC2A. This is EC2B. The files are here. ls, ls. And now we're just going to run the code. Java-jar. Our code is working there. And now we're going to run java-jar face detect. And now we're running our code. And as you can clearly see here, this was listening. It's processing image 1, processed image 2, 3, 4, 9, 10, 11, 12, and you can see the count going down. We processed image 12, it sent out the signal -1, terminated the program. Now if I go to ls, if you go to cat detected text.txt, and we can see everything. and that was my submission for assignment one.